What's up, everybody? Today I want to talk a little bit about limits. What they are, what they're used for, things like this. So, limits in math are what tends to happen to a function as we approach something. So, in life, well, we could say limits happen all the time. We could say, what happens as we approach bedtime? We get sleepy. What happens as we approach old age? We start to have problems holding in our bowels. I mean, there are a lot of things that happen as we tend to get to things, as our lives progress. So, in math, the same thing happens. And we are concerned with what tends to happen. So the most important thing in these limits is not what actually happens at a point, but what tends to happen. You're going to hear me say this word tend a whole bunch of times, so I'm sorry if you find the way I say it annoying, but I need to emphasize that limits are what tend to happen as you approach something. Alright, so let's take a look. We're going to give you an example, and I'm going to show you what I mean by tend. We'll start off with a simple one. So we're going to call this an example. Call this example 1. Let's do x minus 7. Let's say we have a function x minus 7. That's not too bad. Any person taking this class who are introduced to limits at this point should kind of understand at least a little bit what we need by when we say x minus 7. So we're going to make a little table. Tables that we've all seen. And we're going to see what happens as this function tends to get to the number 7. We don't necessarily care what happens at 7. Actually, we don't care what happens at 7. But we're going to see what happens as we tend to get to the number 7. And this tend will get more important as we do future examples. So just bear with me while we do this boring one. So let's go ahead and start with 6, and we'll slowly get to 7. We'll do 6. We'll do 6.9. We'll do 6.99. We'll look at 6.999, and we'll see what value we get in each of those. Let me bring up my calculator because I really. No. Why would I need my calculator? We don't need a calculator. Alright. 6 minus 7. 6 minus 7? Minus 1. That's not too bad. 6.9 minus 7. Minus 0.1. 6.99 minus 7. Minus 0.01. 6.999 minus 7. Minus 0.001. So anyone watching this video, I mean, I almost got scared too, because when I see decimal points and I see 999, but you automatically say, oh, geez, let me rip out my calculator. You don't have to rip out your calculator at any sight of numbers. I mean, sometimes it's okay, but, you know, we were given a brain. Might as well use it sometimes. Okay, so let's do one more. Let's do 6.9999, and we're going to get 0.0001. Right? So if you look at this, if you kind of, I'm pointing with my finger thinking you can see me. If you look at how we're approaching here, what are we doing? We're tending to get closer and closer to 0. Right? So if we continue this, we're going to keep getting closer and closer and closer to 0. Eventually, we're going to get to 0.0000000000001, and it's going to keep going and going and going until we actually meet 7. But like you heard me say 1,000,000 times already, it doesn't matter what happens at 7. It matters what happens as we tend to 7. Okay? We're getting closer to it. So in this case, we're getting closer and closer to 0. Obviously, we can get closer to 7 going from 6 to 7, but we can also get closer to 7 from going the other way. We can also get closer to 7 if we start at 7.9, or let's start at 8 and work our way back to 7. Okay, so let's start at 8, and we're going to go to 7.9, 9, then we'll go to 7.99, then we'll go to 7.9, and then eventually we will get to 7. We'll get to 7.1, and then 7.01, and if we keep going, we'll get to 7, but as you know, we don't care what happens at 7, we care what happens as we tend to 7. So 8 minus 7 is 1. 7.999 minus 7 is 0.999. 7.99 minus 7 is 0.99. 7.9 minus 7 is just 0.9. 7.1 minus 7 is just 0.1. 7.01 minus 7 is 0.01. We'll even do one more for all you people out there who want to see another one. 7.001 minus 7, 0.001. As you guessed, here also, just like everything else, what are we tending? We are tending to get closer and closer and closer to 0. But again, we do not care what happens at 7, because a limit is what tends to happen. Okay, awesome. So, let's go ahead and give you notation for that. It's really important that you see that limits are different than just looking at functions, because we are looking to see what tends to happen as we approach a specific number. So, let's look at this. We're going to look at the nomenclature. We're going to look at how it is that we can write these limits, so we can communicate to other people that we're not caring what happens at a specific point, we're caring what happens as we approach it. So, when we talk about limits, we write a lim. Can anyone guess why? If you can guess why, you can leave in the comment section why it is that lim is used here. So lim, and right under the limit, right under here, right after a lim, we are going to write what we are approaching. So in this case, we're going to say we are approaching 7. Voice crack, which is semi-embarrassing. X minus 7. X minus 7. X minus 7. X approaches 7. We are taking the limit for the function x minus 7. This right here, this little expression, tells the reader, tells the observer, hey, buddy, I don't necessarily care what's happening at this 7. I don't even necessarily care if this function exists at 7. I don't care. So don't tell me, because I don't care. All I care about is what's happening to this function as we approach it, as we tend to 7. So, as we saw from this table, and from this table, it is approaching 0. It is approaching 0. People, please don't forget that limits do not care what happens at 7. I did not write this 0 here. I did not write that there because y is 0 when x equals 7. That's not why I wrote 0 there. I wrote 0 here. Because as x is approaching 7, as this function right here is tending to x equals 7, y is tending to 0. We don't care what happens at 7. Remember, we are watching what happens as we tend to it. So, I'm sorry if I